Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. I'll be one of your hosts this evening. This is Julie, and today I am joined by Connor and Goggin. Hello.
Hello.
All right, we are broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. This is Astronomy Night in Canada, where the lineup is all Canadian, starting with ourselves, York Universe, then on to Western Worlds, Quirks and Quarks, and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time. That's Tuesday morning at 2 a.m. UT. York Universe is a production that works in concert with our online public viewing program run by the Observatory team, and that runs between the hours of 9 and 10 local Toronto time. You can head over to observatory.info.yorku.ca and follow the links to the OPV, the online public viewing, to join the chat. Our broadcast is powered by and in partnership with astronomy.fm, the voice of astronomy. For any questions or comments you have about past shows, or if you have suggestions for future topics, please send us an email at observe@yorku.ca. You can always connect with us on Twitter or Instagram at our handle at York Observatory, and on Facebook at Allan I. Carswell Obs. All our programs are free, but if you would like to make a donation, we won't say no. Head over to our website. Again, that is observatory.info.yorku.ca. We'll be monitoring the chat room for questions and to post content. The current weather in Toronto is not fantastic for astronomical observing, so you'll probably be looking at some archival images through the telescope tonight. All right. So, Connor, Goggin, how's it going?
Pretty good. Just actually today had my first in-person class in nearly 2 years, so that was exciting.
People in 3 dimensions. However, did you handle that? Were you attending or teaching?
I was attending.
Ooh. And Goggin, how are you?
I'm good. I likewise just had my first in-person class last week, except I was teaching. So fun times. It's definitely been a change on campus with everybody back.
Wow. Yeah, exciting times. I'm still hanging out at home for the moment. All right. So I hope everyone's been keeping warm. It is that time of year where it's frigid, which does translate to like really good skies usually, which is nice if you can handle the cold.
Yeah, just not tonight though.
No, not tonight, unfortunately. There'll be other nights. All right, shall we head into this week in space astronomy and history? All right, so I think I'm kicking us off this week. So we're going to start with February 7th, 1977, and the launch of Soyuz 24. The crew for this one were cosmonauts Viktor Gorbatko and Yuri Galaskov, who were the backup crew for Soyuz 23, which had failed to dock with Salyut 5 space station, which was where they headed several months earlier. It was the third and final mission to the Salyut 5 station. It was also the last purely military crew for the Soviets and the last military Salyut station. The cosmonauts actually wound up having a sleep period before entering the Salyut station, and they may have had to reactivate the station after toxic fumes forced an early end to the previous mission, having been Soyuz 21. I put a little bit like a maybe there because these military missions are like very mysterious, and so like when you read about them online, there's like a little bit of like this maybe would have happened. Observers have said, etc. You know, we think they did this. Reportedly, that's what they did. So they would have performed biological and materials experiments, presumably finished up the tasks that the previous crew had abandoned, and probably did some photographic reconnaissance since it was a military mission. They also performed a televised air changing experiment, slowly venting air from one end of the station while refilling it with air from tanks that were on the Soyuz, which was a technique that was carried out with Progress transports and later space stations. I'm not quite sure why that would make for exciting television, but there you go. And the Salyut 5 station was deorbited 6 months after their return to Earth.
You know, I guess I didn't realize how many, Salyut stations there were. You know, when we're thinking about space stations, we obviously think about the ISS, maybe you think about Mir, but there are just this whole assortment of these, really small early space stations that, we don't really think or talk about.
It's true. Now I want to know, how many were there? I mean, the program ran for 15 years.
Mm-hmm. Yeah, I'm just looking this up, and it seems that there were 7 of them, which is quite a few for, all across only 15 years.
That is quite a few. I guess when we think space... Go ahead, Gagan.
Sorry. Yeah, I was just saying, stations, we usually kind of have an idea that they'll have longer careers rather than short ones, so that's interesting. But I guess they are early.
Yeah, there's, I guess, definitely a period of experimentation, what works, that sort of thing. And, when you don't have elections keeping you in line, you can spend a bunch of money on making a bunch of space stations and spacecraft and sending them all over the place.
I mean, it's not necessarily, a bad idea to experiment with these smaller and probably cheaper things before committing to something much bigger like Mir or the ISS.
Yeah. I mean, certainly the Russians brought a ton of knowledge with them to the ISS project. All right. Space stations. We will continue to build more. We will come back to space stations. Oh, we will continue with space stations, actually. How's that for a not great segue? Go ahead, Connor.
Yeah, so speaking of small and early space stations, February 8th, 1974 marked the end of the Skylab mission. So in the early 1950s, it was, generally believed that the construction of a crewed station in low Earth orbit was a critical step in winning the space race. As such a station would allow the nation that commanded it to conduct surveillance, weather forecasting, and general science from a strategically advantageous position. It was also believed that such a station would act as a staging point for future missions to the moon and eventually Mars. However, various technological advances made it feasible to conduct Earth observations using uncrewed satellites, which rendered many of these potential uses for a crewed station unnecessary. This was also exacerbated by the fact that the final launch configuration for the Apollo missions did not include a stopover in orbit, instead launching directly from the Earth's surface to the moon. However, interest in a crewed station remained, I imagine, at least partially because of the fact that the Soviets were doing it so often. So this ultimately culminated in the construction of Skylab. Compared to the ISS, Skylab was not particularly glamorous. It was actually constructed inside of the converted third stage of a Saturn V rocket with a total pressurized volume of just over 350 cubic meters, which is about a third that of the ISS. So Skylab was launched on May 14th, 1969. During its launch, it sustained severe structural damage that threatened its mission before it even began. The station actually lost 2 of its solar panels as well as its sunshade. Furthermore, the full deployment of its sole remaining solar panel was restricted by debris. This left the station both with a severe power problem and internal temperatures that would melt the inside of the station if not brought under control. These problems were all solved by the crew of Skylab 2, which was actually the first crewed mission to the station, despite what the name might suggest. A total of 3 crewed missions to Skylab were undertaken during the latter half of 1973, with the station's final crew returning to Earth on February 8th, 1974. By the late 1970s, NASA believed that Skylab was still functionally safe and operational to be reactivated once the still under development space shuttle was brought into service. However, these plans ultimately never came to pass. As the sun entered an active phase, the increased solar activity heated the Earth's atmosphere, causing it to expand. This meant that the station experienced increased drag, slowing it down and causing its orbit to slowly decay. By December of 1978, it was clear that the space shuttle would not be ready in time to save the station, and NASA abandoned its efforts to do so. On July 11th, 1979, Skylab re-entered the atmosphere off the coast of South Africa, breaking up and scattering debris across a section of southwestern Australia. Fortunately, nobody was injured, though NASA was actually fined $400 by the Shire of Esperance for littering.
Okay, that's hilarious.
Yeah, it was meant as, obviously a joking fine, and the town did write off the fine. But I did apparently someone at NASA, raised the funds and actually paid it off.
Nice.
I was gonna say I think NASA can afford that.
I mean, if you're going to scatter your space station across their town, you might as well, pay them the $400 to clean it up.
I feel like there's probably people in places willing to pay that much and more for just a piece of the space station. As this is my piece of Skylab.
Oh yeah,
It's part of my collection.
Apparently, it was a very highly publicized event. Like, people were painting targets on their roof and things like that. Everyone wanted the space station to land on their house for some reason.
That's a terrible idea. Just saying. I'm not sure your insurance would cover that.
Yeah, it apparently broke up at a much...
I think a yard would be a better choice.
Mm-hmm.
Yeah,
Sorry, Connor.
It apparently broke up at a much lower altitude than they were expecting. So actually, large chunks of it actually managed to make it to the ground more or less intact. And so, it's actually displayed in a museum somewhere. I can't remember which one or where.
One day when I visit Australia, I'll put it on my list of things to have whoever's planning the trip for me, because I that's too much mental work for me. I'll get my husband to do it. Figure out where this museum is. Take me to it. Yeah. I find it interesting that, this idea of having a space station as a jumping off point for other missions was yeah, we should do this. And then, no, let's not do this. And now we're back to it again.
Yeah, I was going to say, we've got this going again with the Lunar Gateway.
Yeah. The Lunar Gateway is going to be an interesting beast on its own.
Yeah, I mean, I've heard some, criticism of it by various people saying it's not actually necessary, which, I mean, it probably isn't. I mean, we've demonstrated that we have the ability to launch things directly from the Earth to the Moon. But I mean, still the idea of a space station around the moon is, fun.
It is. And I think, like, it might not be necessary for getting there, but it could mean some, like, more extended study of the moon, right? Like, the Apollo mission's time on the moon was pretty limited. Whereas if you have, you know, if astronauts can, like, go from the space station down to the surface, spend some time, come back up, have what they need, maybe do some analysis or whatever, go back down. Like, I think it could lead to some interesting stuff that wouldn't necessarily be possible if it was just like, okay, we're here for 2 days and then we're heading back.
Yeah, I mean, the promises of the Artemis program, I guess we'll see where it brings us, but it's very exciting to, be living in this era where we're, allegedly going to be going back to the moon.
Yes. All right. So let us continue. Gagan, what have you got for us today?
Hi. So this week in history for me is going to be a pretty recent event, probably one that everybody remembers really well. So about this time a year ago, Mars was a really popular planet because in 2020, when Mars was at opposition, it was also a close approach. And Mars and Earth were the closest that they'll be for about another 2 decades. And a lot of space agencies, 3 in particular, took advantage of this opportunity to launch spacecraft to Mars. And NASA, China, and the United Arab Emirates, well, I guess the USA, China, and the United Arab Emirates, all launched missions within a week and a half of each other. And about 7 months of space travel later, this week last year, the UAE's Hope orbiter and China's Tianwen-1 orbiter arrived at Mars and entered orbit. So they got there on February 9th and 10th, respectively, which is pretty fun. They were both kind of, I guess, I don't know if their orbits were very aligned, but they were going side by side. And these 2 missions marked the first Chinese and Arabic missions to successfully reach orbit around Mars. And both have gone on to successfully carry out their missions thus far. The UAE Hope orbiter mission is still in orbit, collecting data about Mars' atmosphere and hopefully providing some insight into how Mars' climate has evolved from a past Earth-like weather environment that harbored water to its current really arid desert environment with such a thin atmosphere. And part of this will also be looking at why Mars' atmosphere has slowly been seeping away into space and being lost to darkness. On the other hand, China's Tianwen-1 mission included an orbiter and also a lander and a rover mission. The lander and rover were deployed after a few months of being in orbit, and they successfully landed, and overall the mission objectives were to study atmospheric and surface features of Mars, including soil properties and the presence and distribution of water or ice. The success of these Mars missions is, well, it's definitely going to be a really key facilitating future it's going to be really key in facilitating future Mars missions. Like we were saying with the moon missions, it's been really hard to really study the moon in detail because you only have 2 days there and you collect your samples and then you go back permanently. But what the advantage that we have with these rovers and these missions that are going up now is that they're collecting samples and keeping them safe. And all astronauts have to do when they get there is collect them. So they don't have to spend too much time doing that. And basically, that part of their mission is done for them if they do get there in the foreseeable future. And all they would have to do is some analysis. And maybe based on that analysis, they can do further sample deployment missions. So I think it's definitely a promising thing that we had 3 successful Mars missions all back to back. I think it says a lot about the direction space travel is going, where I guess failures are happening less and less often compared to some of the past planetary missions.
Yeah, especially if we look at... Go ahead.
Sorry, I was just going to ask if either of you have seen the the selfie video from Tianwen-1 that was just released for the Lunar New Year.
I have not. I'll have to go see
Yeah,
that.
there's a camera on the orbiter, and they pointed it back at the spacecraft, and you can see, the orbiter itself, and then, the surface of Mars passing below it. It's really quite incredible.
That sounds awesome. These may be like fairly like a fairly recent This Week in History, but I also feel like this time last year, all everyone was talking about was like Perseverance and it was, the helicopter, and it kind of overshadowed these other two missions. So I'm happy to be talking about them now. I didn't I knew they were there. I knew they were happening. But I have to admit, I didn't look too much into them because I was kind of swept away in Perseverance fever myself.
Yeah, they're definitely not. They definitely have not been publicized as much, at least internationally.
And also, NASA's pedigree with rovers is a little bit more advanced, I would say, to the point where, the data we were getting from Perseverance was a little bit, I would say, more prominent than the stuff we were getting from Hope and Tianwen. But it's been I would say, like, I'm glad they are getting recognition later on now that more data is coming out.
Yeah, and you know what? China is like holding its own in the rover business. Like, you just have to look at all the. Go ahead.
Yeah, they just had a lunar rover too, didn't they? Or am I making that up? I might be making that up.
No, you're not making it up. No, you're not making. Well, it depends what you mean by they just had one, but there've been a number of Chang'e missions that have gone to the moon, and if memory serves, they might have all been rover missions, or maybe all but the first. And they've had a lot of success there, and I think they brought back a lunar sample from one of their recent missions. So I really like learning about, when you think about space agencies, you think about, well, we're in Canada, so we think about the Canadian Space Agency. You obviously think about NASA, and you might think of ESA and JAXA, but I like seeing that those are not the only ones out there. Like, there's lots of countries doing lots of space, and that's awesome.
I just double checked. China and the moon were in my mind just because of in December. Its Yutu-2 rover was in the news because it had spotted this mysterious shape on the horizon. And when they went to look at it, it was just a rock.
I mean, on the moon, the odds were good that it was a rock.
This is true.
They're such cute names, too. All right. Shall we continue? Let's move to our next piece, and that's back to me. February 5th, 2002. So we're again somewhat, well, you know what? I have these moments where I'm like, 2002 wasn't that long ago. And it's like, yeah, Julie, that was 20 years ago. So yeah, anyways, depends on your lifespan, I guess. February 5th, 2002, the launch of, I'm not quite sure how this acronym, initialism, combination of the two would be pronounced. I'm going to go with RHESI. So the launch, it was the Remedy High Energy Solar Spectroscopic Imager. so RHESSI, and it was originally just the High Energy Solar Spectroscopic Imager, or HESI, and that was a NASA Solar Flare Observatory. And it was renamed in honor of Dr. Ramity. It was, I believe, the first mission to be named after or in honor of a NASA scientist. It was the 6th mission in the Small Explorer program, and its primary mission was to explore the physics of particle acceleration and energy release in solar flares. So it was designed to image flares from soft X-rays to gamma rays and provide high-res spectroscopy up to gamma ray energies of about 20 megaelectron volts, and it could perform spatially resolved spectroscopy with high spectral resolution. So this combination of imaging and spectroscopy would give a detailed energy spectrum at each point of an image, and that allowed scientists to see where particles in the flares were accelerated and to what energies, and that advanced the understanding of the fundamental high energy processes at the core of the solar flare problem. So our HESI observations have changed our perspective on solar flares, particularly on high energy processes in the flares. It was the first satellite to image gamma rays from a solar flare. It was also the first satellite to accurately measure terrestrial gamma ray flashes that come from thunderstorms. And I found that such flashes occur more often than thought, and the gamma rays have higher frequency on average than the average for cosmic sources. The operations of the satellite ended in April of 2018 after communication difficulties, and it was decommissioned in August of 2018.
Yeah, and apparently it has the potential to become a bit of a news story at some point this year. Because much like Skylab, even though it's inoperable, it's still just barely skimming the top of the upper atmosphere, and so it's slowly over time being dragged downwards, and NASA's expecting that it'll probably finally re-enter and be destroyed at some point this year.
Mm-hmm. It's gonna make a splash, or maybe not. I don't know. Maybe it's just some light.
I assume they maintain some ability to control it, so it's not like Skylab. It doesn't come down wherever it wants to. Though, I mean, if it was decommissioned due to communication difficulties, maybe that's not the case.
Yeah, I read that it doesn't have any more propellant. So I don't know. But it also, I mean, would probably be significantly smaller than Skylab.
Yeah, this is true. So it probably, will disintegrate fully in the atmosphere.
This is sad, but also safer.
It's true.
All right. Well, we're moving from one solar mission to another. Take it away, Connor.
We sure are. So February 11th, 2010 marks the launch of the Solar Dynamics Observatory. So SDO was the first mission in NASA's Living with a Star program, which was intended to study the sun and its effects on the Earth. Other missions in this program have included the Van Allen probes, the Balloon Array for radiation belt relativistic electron losses, the Parker Solar Probe, and the Solar Orbiter Collaboration. SDO includes 3 scientific instruments: the Extreme Ultraviolet Variability Experiment, or EVE, which measures the sun's irradiance in the extreme ultraviolet every 10 seconds, the Helioseismic and Magnetic Imager, or HMI, which measures the sun's magnetic field, and the true workhorse of the observatory, the atmospheric imaging assembly, which images the solar disk in 10 different wavelength channels every 12 seconds. Those images are typically processed and downlinked to Earth within half an hour to be posted on the SDO website, so anyone can see high-quality images of the sun in near real time. Now, interestingly, the launch itself yielded some unexpected science that was entirely unrelated to SDO's primary mission. As the Atlas V rocket passed through some cirrus clouds that happened to be passing over the launch site, it created visible shock waves that destroyed a sundog, which is an optical phenomenon caused by the refraction of light by plate-shaped ice crystals. The shock waves disrupted the crystal's alignment, causing the sundog to vanish. Following the sundog's destruction, a pillar of white light appeared next to the rocket, and it seemed to follow the rocket on its ascent. This was some sort of unusual and unexpected behavior on the part of the clouds, and after some careful examination, it was determined that the shockwave actually caused the crystals in the cloud to rapidly rotate and precess in such a way to create the light pillar that was observed. That's a little bit of fun, unanticipated secondary science from the launch of SDO.
Destroyed a sundog.
It sounds a lot more dramatic than it actually is.
It sounds sad. I love sundogs.
Yeah, the video of it happening is quite spectacular because you can actually see, as the rocket breaks the sound barrier, there are these very visible shockwaves that pass through the cloud.
Well, that sounds awesome. All right. Making a note to go watch that.
Providing lots of video recommendations to you both today.
Indeed. Just making, like, I'm literally making notes, like, go watch this. Excellent. Okay, so the launch yielded some cool stuff. And I'm assuming the probe itself has also yielded some cool stuff.
Yeah, of course. It's still operational. You can go to their website and see what the sun looks like right now.
Ah, yes. Now I know the one you're talking about. The one with all the pretty colored suns.
Mm-hmm. It sure is. Yeah, I don't know. For some reason, I'm always impressed by, any photo taken of the sun like that. I understand how camera technology works. I know that this is something that we can do, but it seems really just impressive in a way that we can, take these incredibly detailed photos of this object that will blind you if you try to look at it.
I agree. I find pictures of the surface of the sun like disconcerting on a texture level.
Yeah, those little convection bubbles are very weird, particularly when we think about the fact that each of them is larger than the entirety of our planet.
I hadn't even thought of that. Not only does it bother me on a texture level, it's like giant. There's just something about it. Like, I don't think I'm one of those people that's afraid of holes, whatever that phobia is. Because I can't remember the name of it off the top of my head. But there's just something about that texture that I just like stare at it. I'm like, it just feels wrong.
Yeah, it's something that you feel like you shouldn't be looking at it just because you're always told don't look at the sun. It's bad for your eyes. Again, and yet here we are looking at the sun and perceiving its extremely small details.
Well, maybe that's it. Maybe that's what bothers me about it. Stop staring at the sun. All right. Gauguin, you are the one with the last piece for our This Week in History. What have you got for us?
Yeah, I'm going to run through this one a little quick because I think we have to get to our mid-show reminder soon. But I
Oh, we're
think
good.
we got a fun one, especially because Valentine's Day is right around the corner. I think our next show will be on Valentine's Day. But this one falls into the jurisdiction of this week for This Week in History. So, for anybody listening, I would just like for you guys to think of the absolute biggest diamond you can think of. And now, in your head, think of a diamond way bigger than that. Like the biggest possible diamond you can conceptualize in your brain. If the diamond in your head is in the ballpark of, I don't know, 5 times 10 to the power of 29 kilograms, then I applaud you for your imagination, because that is the approximate size of the biggest diamond in the universe as told by astronomers in February 2004. For reference, that's 5 with 29 zeros behind it. And for comparison, the Earth only weighs 6 with 24 zeros behind it. So this diamond is 5 orders of magnitude bigger than the Earth, or more massive than the Earth, I should say. And it's actually the core of a star called BPM 37093. And I know that's a mouthful, so it's nicknamed Lucy after the Beatles song, Lucy in the Sky with Diamonds. Lucy, as I'm going to call the star because that name is a lot, it's a variable white dwarf star in the constellation Centaurus. And since it's a white dwarf, its material crystallizes as it cools in the core. And this particular star is made mostly of carbon. And so astronomers realized that the core could be considered in large part a diamond, because that's what a diamond is, just really highly pressurized crystallized carbon. So while we haven't had any close-up images of this star, nor do I think we can mine it, even though that would be pretty cool, this is a pretty cool thing to imagine. Just a massive diamond, probably bigger than the Earth, or about the same size, because I know diamonds are very dense, just floating out there in space. And it's lighting up the sky, around it at least. But yeah, pretty cool thing to think about.
Yeah,
That's
stars.
fantastic.
Yeah, stars are really, fascinating objects. You get these incredible pressures and temperatures in their cores, and cause all sorts of wild and fun physics to happen like this.
Yeah, absolutely. And the fact that most diamonds on Earth are made by the pressure caused in the mantle or in volcanically active areas. So I definitely think that the pressure in a star's core would be more than enough to create diamond from carbon.
Yeah, I would agree with that.
Trivia question. What was the world's largest diamond found thus far, I guess?
I can't remember the name. I think it was the Royal Jubilee. And I think it was over 500 carats, but I'm gonna have to look up how many grams that is. I think it's the Royal Jubilee.
I mean, that probably ranks along the biggest ones, but the absolute biggest one. And this is I'm rough diamond, not cut diamond.
Oh, rough diamond. Okay.
Yeah.
I'm not sure. There is. Am I saying? Okay, I think I meant the Golden Jubilee, but I'm not sure how big the largest rough diamond would be.
So the largest rough diamond was the Cullinan diamond.
Oh wow! And how big was that?
It was 3,106.75 carats. That is 621.35 grams. And 9 diamonds were cut from it that are in the crown jewels, the British crown jewels.
Wow. So still not even a kilogram.
Yeah. So this white dwarf.
I'm telling
That's
you,
a lot of diamond.
If anybody can get to this white dwarf, you may have a bag on your hands.
Yeah, how many crown jewels do you think you could cut out of this?
So many. You got to figure out how to get to the core of the star first, though.
That's true. That's very true. It would be quite a mission.
Think it would be a challenge. All right. That was a great one to end this off on. Thank you, Goggin, for that great piece. So if you're just tuning in, where you been? You're late. You're listening to York Universe, broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. You can head over to observatory.info.yorku.ca for chat, questions, and content by joining the online public viewing. So just follow the links there. You can reach us on Twitter and Instagram at York Observatory, and on Facebook at Allan I. Carswell Obs. And tonight you are listening to myself, Julie, as well as Connor and Goggin. So we have just finished our weekly This Week in Astronomy and Space History, and we are going to dive into the news. But before we get to that, just one reminder, our Monday night programming you're listening to right now, but we also have Wednesday night programming. That would be Teletubes on Wednesday evenings. Tune in at 7:30 p.m. That's local Toronto time to our YouTube channel. And the observatory staff will have something fun happening. I'm not sure what's on the program for this week, but it's always something good. All right, now on to the news. Connor, what have you got?
So for my piece of the news this evening, it's actually a bit of James Webb's news.
Hooray!
So following James Webb's successful launch and deployment, the 3-month-long process of aligning the telescope has begun. Late last week, the first interstellar photons successfully traversed James Webb's optical path and were detected by the Near-Infrared Camera, or NIRCam. You may remember hearing that we won't be getting images from JWST until this summer, so it might be surprising to hear that first light has already occurred. However, the images that are currently being taken are not particularly pretty, as the telescope's 18 primary mirror segments are still unaligned. These first images are being used to fix that in a 7-step procedure that is both fascinating from a technical standpoint, but also too lengthy to discuss in much detail here. What we really care about is the fact that in 3 months, at the end of this process, we will have new images set to reveal the early days of the universe in unprecedented detail. And as a little fun fact, JWST's target for alignment is HD 84406, a star located in Ursa Major. This star was chosen because it is relatively bright, with an apparent V-band magnitude of 6.9, and fairly isolated, so there won't be any other bright objects in the telescope's field of view during alignment.
Sorry, I forgot to put my phone on silent. Yay! Light! Yay, telescope. Sorry, I am so excited about this. It's also like, oh my goodness, 3 months. Everything about this telescope is so big. Like,
it's true. It's
right? It's just like, I take everything from my experience of getting my first telescope, and it's just like, stretch it out in time. Just stretch it out. It's going to take that much longer. Alignment. 3 months.
Yeah, I mean, no. I would prefer that they take those 3 months and actually, get everything working perfectly so that when we do get those first images, they will be really spectacular.
Oh, yeah, absolutely. I'm not saying don't do it. I'm just like, I want to get to the pretty pictures.
Yeah, we don't want a repeat of the Hubble, knock on wood, and what happened to them the very first time they put it on.
Exactly. I mean, advantage here, the mirror is adjustable. So
That's true.
It won't, and that's important because unlike the Hubble, we can't send a space shuttle out there to add a piece of equipment to it to fix anything. Too far.
Yeah. No
I can only...
sending humans at that speed to get there in 6 months yet.
Yeah, I would love to be, in the control room when those first images do eventually come down. Yeah, I mean, I've seen video of what happened when the first corrected images from Hubble came down. And these, very professional grown men just like in tears at how beautiful these images are.
Well, you won't be in the room, but I'm sure that there'll be a broadcast because that's become the thing. And I think it's fantastic.
It's an expensive thing, so you might as well, publicize it a little bit.
Absolutely. And it's also I love watching the control room footage of stuff because you can feel the nervous energy of the people who, like, these are projects they've been working on forever, like entire careers in many cases, right? So like it all comes down to like that moment, and it's so great to see science represented as more than just like, yes, I am in a white lab coat behind a microscope, even though I'm an astronomer. Just me?
Oh no, it's definitely true. I mean, going back to Perseverance, like seeing, the absolute joy, erupting in the control room when, they received, word that Perseverance had successfully landed. It's, obviously I don't think, I was not involved in that. And so, it's not really my joy, but it's still joyful seeing, all these people being, so purely happy about something that they've worked so hard on.
Yeah, especially projects as long as these. These are, decades worth of work. And by and large, it's usually the same crew that starts and people get added on, but there are a lot of people who have been there since the very start, and it's pretty awesome to see them celebrate their achievements.
Absolutely. All right. Let's move on to our second news story. Gagan, this is you.
All right. So I feel like we talk about delays all the time on York University, but I feel like we said, that's what it takes to make sure things go smoothly, and so you don't have to redo a mission, which is hundreds of millions of dollars. But I'm going to be talking about another delay today, which is the delay of the wet dress rehearsal of the Space Launch System. So the Space Launch System is an upcoming single-use launch vehicle system that NASA is developing, or has developed, as a successor to the Space Shuttle system. There was actually another program, Constellation, and the Ares class of rockets that were meant to be the succeeding launch vehicles, but this project was canceled due to budget and development constraints in the early 2010s. So never really forward. And so founders launch system of both Space Launch System and return to the moon. And they 20 act since that project was scrapped, and the current still in it has its sights set project now. first Artemis test mission, an uncrewed test mission on the rocket Orion, launching Orion to the moon to kick it off in April. However, Artemis and Orion might have to wait a little bit longer. While the initial test launch, Artemis 1, has been delayed significantly from an original planned date in 2016, the full wet dress rehearsal schedule that was scheduled for this February has been postponed another month to March, just for some more technical and fine-tuned adjustments. And the wet dress rehearsal is basically a big mock launch where the full launch procedure is carried out with the launch vehicle fully assembled with the payload attached and all the liquid propellant and fuel loaded into the vehicle. Basically, it's the entire launch except firing up the engines and launching. We're pretty close to the first Artemis launch. Like I said, they want to launch the very first Artemis test mission, which is going to be Artemis 1 in April. And this wet dress rehearsal is basically the last major test on the checklist. Going to the moon and flying back is the first crewed mission to orbit since
Yeah, little fun fact about Artemis 2 is that it's going to send the first Canadian out of um, 2020. Artemis 2 is going to include 3 NASA astronauts and 1 astronaut from the CSA.
Yeah, that's awesome.
I'm assuming they haven't announced which one yet, have they?
They have not, no.
I'm so curious.
They did announce they have a short list of 18 astronauts. And it's 9 men and 9 women from several different countries. So they said that at least the primary Artemis missions will consist of members of this elite little group of astronauts.
All right, looking it up. Because, we don't have that many active astronauts to choose from.
No, a lot of them are up and coming pilots who I think are currently in astronaut training programs or have just reached astronaut status. I'm not sure many of them have really spent a lot of time in flight besides, Earth flight. So I assume we still have 2 years until the first crewed mission. So I assume they will be logging some ISS hours between now and then.
Yeah. I found an article that lists the 2 most recent, Joshua Kirtrick and Jennifer Sidey-Gibbons, as being on the short list.
Nice.
All right. Okay. Sorry, I'm poking at things because I need to see this. Okay, cool. Yeah, no, looking forward to these missions. I think it's going to be super exciting. And yeah, I fully expect a flurry of maybe somewhat similar to, like, if you look at the STS missions, at the beginning it's like they went up and they did, they launched a satellite and they did this and they did that. And like, if you look at like the last bunch of them, it was like ISS, 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 ISS. So there'll certainly be some gateway building Artemis missions in there eventually.
Definitely. All
right, so we've got time for one more. This one's mine. Back to the ISS. I came across an article this week that was entitled "The ISS to Crash Down to Earth in 2031," and I was like, let's read this. So NASA announced the ISS will continue operations until 2030. This is if the partners agree, and then splash down in early 2031 in the Pacific Ocean at Point Nemo, which is also known as the Spacecraft Cemetery. Point Nemo is the farthest point away from land on Earth, and many satellites and other things, such as Space Station Mir, have landed there for safety. The ISS has been in orbit since 1998 and has been continuously crewed since 2000. And over 3,000 research investigations have been completed on board so far. It's operated by 5 space agencies, and they all have to agree to the extension. So at this point, it's only been approved to operate until 2024. The Biden administration in the U.S. has said it's committed to extending the mission to 2030. And the head of Russia's space program has indicated willingness to work with NASA beyond 2024. But the current political situation between Russia and the rest of the world might make these dealings difficult. We'll see. NASA has also said that future near-Earth space activities will be led by the private sector, and has, in the past while shown a shift towards that. For example, they've contracted Axiom Space to build a module to attach to the ISS in 2020, and then provided funding to 3 companies to develop designs for space stations and other destinations in orbit. Moving to having near-Earth privatized will save them $1.3 billion. I'm assuming that's annually, and that will be moved into deep space exploration. My first thought was like, but why have it splash down? Why not transfer it? But apparently by 2030, there will be significant structural fatigue. That may mean the end of the ISS anyway. Will be the end of an era.
Yeah, it's quite sad. I keep saying that, things like the ISS or, Hubble, I think they deserve better than, being disintegrated in the atmosphere. They're incredible technological achievements. It's just sort of sad to see them destroyed rather than preserved for, future generations.
But it would be hard to get the ISS back down safely to Earth, unfortunately. All right, folks, on that note, you have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, and alumni and friends of York University. Your hosts this evening have been Gagan, Connor, and myself, Julie. Stay tuned because it's Astronomy Night in Canada. Up next is Quirks and Corks, Western Worlds, and Science for the People. Please connect with us on Twitter or Instagram at York Observatory, and clear skies.